Welcome to Sctfisteve's Museum of Circa 1950 Spaceships. Today's tour is of the rocket used by Buck Rogers. The ship is shown here as a compilation of several comic books, images from the internet, my childhood memories, the website Rogers Rocket Ships, and my father, who had a great deal of input. The rocket as shown here is some 65 feet long with a diameter of 12 feet. The wingspan is 35 feet tip to tip and has a dorsal fin of some 12 feet. The thrusters on the wingtip are some 5 feet in diameter and approximately 22 feet long. Maneuvering of the ship is done via control thrusters in the nose and tail. Its design is a classic meteor shape with a rounded nose tapering to a long, narrow rocket thruster. Period true rocket tubes in the tail and a large glass window for navigating the rocket make this a classic for the period. There's a single starboard door for entering the ship. Buck's companion in space were a young boy named Buddy and a female companion named Wilma. So the rocket is set up for a crew of 3 and is designed as a single-stage rocket for interplanetary travel. The craft is atomic powered with air-breathing jets on the tips of each wing. The rocket is designed to normally take off and land horizontally, but it can land on its tail and take off from there. The setting is the distant future in a stellar system teeming with a wide range of intelligent life everywhere. First to roll out is the flight deck. This is just a placeholder. I want you to see how big it is in relationship to the rest of the ship. Besides the deck itself, you can see the water and air bottles located at the rear, plus their recycling, plus the associated generators and small steam engine to drive the generators. Propulsion and power systems. In designing the ship, I'm thinking fuel for the atomic engine is something he would need to be concerned about when traveling the solar system. So, the atomic engines are designed to burn a generic fuel. Simply anything liquid or gaseous that can be burned under 6,000 degrees could work. The engines are based on the atomic engines built and tested by NASA and the Department of Defense in the late 60s. Project NERVA, N-E-R-V-A, was a very successful attempt to build a practical atomic engine for rocket flight. In the center line of the ship are 2 atomic reactors. The first and largest of the 2 runs 24/7, not only for propulsion, but to provide electricity for the ship. The second and slightly smaller reactor produces the hot gases necessary for propulsion. The fuel, either a gas or liquid, enters the first reactor and is heated probably around 2,000 to 3,000 degrees. This way the propulsion reactor, the second reactor, always deals with a consistent medium. The second reactor heats the gases to approximately 5,500 to 6,500 degrees, creating the exhaust expansion necessary for thrust. These numbers, by the way, are consistent with NERVA project, N-E-R-V-A. After the second reactor, the heat expansion passes the gas through what I call ram tubes and out the rear. The tubes are actually similar to the Bell X-1, which used an elongated cylinder instead of the general ball and bell shape. To conserve on fuel, the wing thrusters are jet engines and not rocket engines. They can only run in an atmosphere, but the chemical makeup of the atmosphere is not important. Any gaseous material could flow through the engines and be expanded enough to create the needed thrust. The heat from reactor 2 is transferred via liquid metal to the wing engines. A cylinder with small Ticonderoga pencil-shaped holes heats the air passing through it, expanding the gases enough to create the thrust needed for flight. I patterned my engines after the HTRE, General Electric engines of the late 1950s. This design comes from the U.S. attempt to build an atomic-powered aircraft. Nuclear engines for propulsion aircraft, NEPA, of the 50s, was very successful but never implemented for political reasons. A flying atomic reactor over your head makes the public nervous. The general engine design that I used is based on the SR-71, which uses a combination of turbofan and ram air for airflow control. For those of you who doubt the ability of a plane to fly using nuclear engines, the old Soviet Union in 1961 converted their bare intercontinental bomber to test their atomic engines, and it worked. Next to roll out are the vertical lift engines. These engines are located directly under the bridge or main deck. There are two engines. They're just about identical to the wingtip engines, except that these only burn fuel. They don't draw in any air whatsoever. And they're vented so that they point down. One engine has a vent that goes down in the aft. The other one has a vent that goes down in the bow. These engines get their fuel from the two wing tanks, the lower ones. I did not duct anything to the upper tank. I don't know why. And they get their heat from the second core reactor, thus expanding the gas or liquid and then jetting it straight down. The ships from the 30s, the rocket ships from the 30s, that is, had very thick wings because the models that they used needed to be thick because they bounced them around and they didn't want to see them flex. So I took advantage of that and I made the wings very thick and I put the fuel tanks inside those wings. Both the dorsal and two wings all have large fuel tanks, which you can see here. The fuel is brought into the top of the first reactor. This is the only entrance to the rocket. The first control panel on the right is for the door and the decompression procedures. They close the door, move the lever from left to center, and then center to right, lifting the door and locking it in place. The lights reflect the status. The first chair on the right is the science station with the attached control panel. Both swivel and the panel moves out for easy access. The pilot's chair is raised higher than the other two chairs, and this gives him a clear view out the top forward window plus all of the surrounding windows. On the port side is the radio operator's chair and control panel. On the right, you'll find cabinets for storage, such as food, extra parts, machinery, things like that. Just beyond the cabinets is a three-tiered bunk for all three passengers, and just beyond that is a private bath latrine for cleaning up and washing up. The back wall holds the engineering panel for the two atomic reactors. Large knobs and big throw levers dominate the control panel as we see it. The large knobs at the bottom, which look like beer tappets, actually pull out. They're graduated. They have an indicator of what you're doing. You throw it over to lock the position, and then you push it back in. When you push it back in, it engages and the light comes on. On the left, we have a small, medium, and large spacesuit collection for Buddy, Wilma, and Buck. All three have their glass helmets located just above, followed by the rocket packs, which contain their air recycling and radio communication, followed by their ray pistols, which are attached to the wall. Alrighty, this is something I always wanted to do. We're going to move the ship into vertical launch position. As that happens, you'll watch the grid in the glass area in the nose travel down. The ship's moving up into a vertical launch. The chairs will also rotate into a vertical launch position as the ship is now pointed upward. Also, we're going to extend a ladder, so once the ship is in the vertical position, you can still traverse the ship by traveling up and down the ladder. You'll notice there are small platforms that will extend so that you can go to the door and a ladder outside to take you to the bottom. From the outside, you can watch the pilot's chair move into position. I want to thank you for your time. I hope you enjoyed all the drawings, and that concludes our tour of Buck Rogers' rocket.